So this next video is going to be applying what you just learned in the last video. So what we're going to do is just express the following in terms of sums and differences of logarithms, and then we're going to express sums and difference of logarithms as a single logarithm. So we're doing it of more. So this is the log to the base a of x squared times y to the 5 divided by z to the 4. And the easiest way I can explain this is that anything multiplying, you're going to add, and anything dividing, you're going to subtract. And the rule is that anything that's on the top is multiplying. This is all multiplying. Anything on the bottom is dividing. So to keep this simple, anything on the top we add, anything on the bottom we subtract. So this will be log to the base a of x squared plus log to the base a of y to the 5 minus log to the base a of z to the 4. And that's as simple as that. So the textbook goes through this whole thing where they show you that it's like the numerator getting divided by the denominator, and then you got to use brackets. I'm like, just keep it simple. Anything on the top is multiplying. Anything on the bottom is dividing. Now, this isn't quite done. To express this in terms of sums and differences, you're not allowed to have the exponent on the of. So they also want you to apply the power rule to bring the exponents all down in front and then simplify where possible. So this would be 2 times log to the base a of x plus 5 times log to the base a of y minus 4 times log to the base a of z. And that's it. So keeping this simple, let's do this one. We're looking at this one. Again, anything on the top is multiplying. Anything on the bottom is dividing. Now, here's where people get really confused. This is the log of a times y to the 5 divided by m to the 3 divided by n to the 4. Both of these variables in the denominator are dividing into the numerator. So there's this whole long way that you can do this, but the simple way for me to write this, again, I'll show you, I'll leave a couple lines because I'm going to put the long way that the textbook does. But what I would love is if you jump straight to, this is log to the base 10 of a plus, because it's multiplying, log to the base 10 of y to the 5. And then the bottom things are subtracting. So minus log to the base 10 of m cubed minus log of n to the 4. If you can jump right there and you're comfortable with that, awesome. If you're not, maybe you need a couple of steps. Maybe you need to see that this is log of a y to the 5 minus log of m cubed n to the 4, because maybe you're looking at the fact, hey, this is division, I want to do that whole thing as a subtraction. Then maybe you can see, hey, these are multiplying, so now I can write this as log of a plus log of y to the 5, and then from that I'm going to subtract log of m cubed plus log of n to the 4. So I'm showing you this because what I want you to show is that both the things in the denominator are getting subtracted. You can do that straight away, or you can be like, oh, but I see it as a multiplication and I don't get it. And that's totally understandable. And you could say, okay, well, on the top you have a multiplication, on the bottom you have a multiplication, but you're subtracting that multiplication. And so this will end up as minus log m cubed minus log n to the 4. So however you get there, if you want those first two steps or not, that's where I want you to get to, and then simply bring down your exponents. So this would be the log of a plus 5 log y minus 3 log m minus 4 log n. All right, last one, and I was regretting when I was teaching this in class not leaving more space. So try to start as high up as you can here. So the first thing I want you to notice is that this is the step up. So I kind of went these gradually harder and harder. So the first one, you'll notice we only divided by one thing. Okay, pretty simple. Then we divided by two things. Ooh, I have to subtract both of those? That's weird. They're multiplying. Yeah, but they're dividing into the numerator. This one, there's this cubed root thing. So what I would want you to do first is realize that that could be an exponent on your of. So this is log to the base a of a squared b over c to the 5, all raised to what exponent? How would I write the cubed root of all of this as an exponent? Again, the index of the radical becomes the denominator of your exponent. Okay, so what you're going to then do is say, okay, that makes things complicated. I'm going to bring that 1/3 in front. I'm going to use my power rule. So this is really 1/3 log base a of a squared b over c to the 5. And then you're just going to leave that 1/3 out front. It's going to stay here. And I'm going to express this as a sum and difference of logarithms. So I'm going to say, okay, this is log to the base a of a squared plus, because this is multiplying, it's on the top, log to the base a of b, and then minus, because it's dividing, log to the base a of c to the 5. And that 1/3 is multiplying by all of that. So now it doesn't matter what order you do this in. You could multiply your 1/3 through, or you could bring your exponent down first. It doesn't matter. But we need that 1/3 to go in front of everything. So I'm going to do that first. I'm going to multiply the 1/3 through. So this is going to be 1/3 log base a of a squared plus 1/3 log, oops, that came out weird, log I'm having pen issues, log base a of b minus 1/3 log base a of c to the 5. And again, you could have brought your exponent down first and that would have been fine. Or you could multiply the 1/3 through. I multiplied my 1/3 through, and now I'm going to bring my exponent down. So the exponent's going to come in front and multiply. So this is 2 times a third. 2 times a third is 2/3. So 2/3 log base a of a plus, there's no exponent to bring down, so 1/3 log base a of b minus 5/3 log base a of c. Sweet, am I done? So what you want to check is, can you simplify anything? Well, hopefully you see this guy, log to the base a of a. A to what exponent is a? 1. So this would be 2/3 times 1 plus 1/3 log to the base a of b minus 5/3 log to the base a of c. And because none of these are like terms, right, it's 2/3 times 1, and then 1/3 times log to base a of b, and then 5/3 times log to base a of c. None of these are like, I'm done, right? That's as far as I can go. All right, now we're going to go backwards. Now I put these in the wrong order, and I'm going to fix that. But let's do this one first, because this one is the direct opposite of what we've been doing, and then we'll do this guy last. So when you look at this one, I want to go from a sum and difference of logarithms back to a single logarithm. So to do that, we have to do the exact opposite of what we just did. So this one is kind of the exact opposite of this first one way up here. So what did we do last? Well, we brought the exponent down. So the first thing we're going to do is bring the exponent back up. We're going to do the reverse of the power rule. So I'm going to write this as log to the base b of x to the 5 minus, there's no coefficient, so log to the base b of y, plus log to the base b of z to the quarter. Now I can apply my sum and difference rules back to going to a single logarithm. So I'm looking whether things are additions or subtractions. Now this one's weird. All the other ones we did, the subtraction came on the end, because that's how we would do it, right? We would say, oh, the division, I want that guy to go to the end. Well, in reality, it can go on the end. The commutative property of additions is it doesn't matter what order we add and subtract these in, right? We can go log to the base b of x to the 5 plus log to the base b of z to the quarter minus log to the base b of y if we want. Or you can just think of anything subtracting as division. It goes on the bottom. So let's start by writing our single logarithm. So log base b of what? Well, anything adding is going to be multiplying, so it's going to go on the top. Anything subtracting is going to be dividing, and it's going to go on the bottom. So this is going to be x to the 5. Now it's subtracting log to base b of y, so it's going to divide by the y. And then it's adding log to base b of z to the 4, so z to the quarter. So z to the quarter is going to go on top. So again, if it makes more sense to rewrite the order and then do it, that's fine. You know, I think the textbook would even walk you through writing this as a single logarithm first. So log base b of x to the 5 over y, and then multiplying that by z to the quarter, which puts it on the top. I'm like, just do it all at once. If it's an addition, put it on the top. Subtraction, put it on the bottom. Now, is that your final answer? Sure. Right? That's great. Or if you really want to, you could write this as log to the base b of x to the 5 fourth root horrible at my fours, sorry. Fourth root of z all over y. I often do a bracket just because it looks horrible. Doesn't matter, totally an or. All right, let's finish off with this one. So this says expresses a single logarithm, and it's only 2 terms. So this is no different than the ones we did when we started learning the laws, except there's something more that we're going to do with these. So since you see a difference, that means anything after the subtraction is going to go in the denominator. So this is going to be the ln of 3x plus 1 over 3x squared minus 5x minus 2. Now, that's great. What you want to look for is, can you simplify it all? So to simplify, anytime you see a squared, factoring should come to mind. I see a squared and I'm like, ooh, can I simplify this by factoring? Well, sure. So how am I going to factor it? Well, I have 2 choices. My numerator is not going to factor. It's 3x plus 1. My denominator is a trinomial, so I know it's going to factor down to the product of 2 binomials. What are those 2 binomials going to be? Well, I have 2 choices. I can do the AC method. I can go 3x squared minus 5x minus 2. I'm looking for 2 numbers that multiply to give you negative 6 and add to give you negative 5. So 3x squared minus 6x plus x minus 2. Then I can factor by grouping. So I'm going to take out a 3x to be left with x minus 2. Don't have to factor anything out of there, so I'm going to take a plus 1 to be left with x minus 2. And my 2 brackets are 3x plus 1 and x minus 2. All right, and that's what I'm going to put in here. Alternatively, if you're kind of getting to this point in math where you're like a little bit bored of the AC method, you're welcome to start doing trial and error. Trial and error works by thinking about what would go in the 2 brackets instead of going through a whole process to get there, just like, what would it be? Well, to get 3x squared, that would be 3x times x. Those are my only 2 numbers that multiply to give me 3. So that's pretty nice. And again, there's only 2 numbers to give me 2, so this is a great one to do by trial and error. The 2 numbers that multiply to give me 2 are 2 and 1. And all I have to figure out is which bracket's going to get the 2 and which bracket's going to get the 1. Well, I know my inners and my outers are what going to get me that negative 5. So I know I want the 3 times the negative 2 and the x times the plus 1. Because that is going to add to give me negative 5x and still multiply to give me negative 2 on the end. All right, then from there, can I simplify? Well, I have a common factor of 3x plus 1, and so this is going to be the ln of 1 over x minus 2. All done. All right, so the last application. I should really make this another video. You know what? I'm going to make another video.